The light-independent reaction, also known as the Calvin cycle, can be looked at in terms of being a cycle, but also can be looked at in terms of a series of individual reactions, and I think that's the easiest way to consider that. So we'll start off, we're dealing with one molecule of a compound known as RUBP, ribulose bisphosphate. RUBP is fine. This is a 5-carbon molecule, and this is being converted to 2 molecules of glycerate 3-phosphate, and I'm going to write them out separately. So glycerate 3-phosphate and another glycerate 3-phosphate. Now glycerate 3-phosphate is a 3-carbon molecule, so obviously we need a carbon from somewhere, and this is where CO2 comes into this reaction. Now for this to happen we have an enzyme called Rubisco involved. Now the next phase of this reaction is taking the 2 glycerate 3-phosphate molecules and converting them into molecules of triose phosphate. So we have 2 molecules of triose phosphate. Now triose phosphate, again, 3-carbon molecule. Now the reason why I've changed colour here is that this is a reduction. Triose phosphate is a reduced form of glycerate 3-phosphate. In order for this reduction to occur, an oxidation must also occur, and that oxidation is when NADPH2 is converted to NADP. That is the oxidation, but also as this is happening, ATP is converted to ADP and inorganic phosphate. This obviously has to happen twice, once for each reaction. So NADPH2 going to NADP, and then ATP going to ADP and inorganic phosphate. But at this point the numbers start to stop making sense. So at the moment we can see the reactions occurred from RUBP being converted to glycerate 3-phosphate, glycerate 3-phosphate then being converted to triose phosphate. The triose phosphate, being a 3-carbon, one is used to make glucose. The other goes back to the beginning. Obviously, you can tell right away the numbers don't add up. We're going from a 3-carbon being used to help make glucose, which is our 6-carbon molecule, and then we've got another 3-carbon going back and making a 5-carbon. The way that we link all of this together is by doing this reaction 6 times. So if we build this up from the beginning, starting with the 6's, so if we have 6 RUBP with 6 CO2 coming in, they would be converted to 12 glycerate 3-phosphate. I'm just going to abbreviate to GP for the purposes of this. Those 12 GP then get converted into 12 triose phosphate, which again I'll abbreviate to TP. This is happening 6 times, so there would be 12 NADPH2s going to 12 NADP, and then there would be 12 ATP being converted into 12 ADP plus pi. And now I just want to zoom in on this bit, the 12 triose phosphate, because 2 of those triose phosphate leave at this point and are used to produce glucose. 10 of the triose phosphate are converted into 6 ribulose phosphates. I'm just going to use them as RP. And then these 6 ribulose phosphates are converted to our 6 ribulose bisphosphate. If I just move up. Now we're going from a single phosphate molecule here to a double phosphate molecule here. So in order for this to happen, 6 ATP are converted to 6 ADP, with that additional phosphate being provided by the phosphate from the ATP. So if we zoom out and consider what we've just gone through there, we start with our 6 RUBP. Our 6 RUBP converted to 6 CO2. That produces 12 glycerate 3 phosphates. They are converted to 12 triose phosphates, 2 of which, which is 6 carbons in total, go to produce our 6 carbon glucose. 10 of which is 30 carbons in total, goes into our 6 RUBP, which we started with, which, if you think that the RUBP is 5 carbon, there's 6 of them, that means that there are 30 carbons in total there, and the numbers all follow through now.